Hi everyone. Today I will teach us how to solve problems on electric circuit. Yes, how to solve questions on electric circuit. Let's take the question first. The question says, an electric heater of resistance 110 ohms is connected to a 220 volts main supply. The time it takes to dissipate 121 kilojoules of energy is, as I said earlier, I want to teach us how to solve problems on electric circuit. Yes. Now, the question says that an electric circuit, which is electric heater in this case, has a resistance of 110 ohm, 110 ohms. Okay? And it is connected to a 220 volts main supply. Okay? Now, the question asks us, the time it takes to dissipate for this electric circuit, electric heater, to dissipate, to give out 121 kilojoules of energy is what? So, from the question now, we know that the question is asking us of time. The question now wants us to get the time of the electric supply. Okay, now they give us energy. So we now ask ourselves, what is energy? From the simple definition of energy, we know that energy is simply defined as the capacity to do work. Okay, mathematically we say that energy is work done. Energy, mathematically we say that energy is equals to work done. Yes. Mathematically, we say that energy is equals to work done. Now, I want us to ask ourselves again, work done by what? I want to explain briefly to us this work done. Yes, I want to explain briefly. Now, in our different offices, work are done by human beings or by machines. Why? Because the human being or the machine are the workforce there. So the work are being done by the workforce. So from this, we know that work are done by workforce in different parameters of life. Now, in electric circuits, as we have on the board, what are the workforce that are doing work or that does work in the electric circuit? The workforce that did work in electric circuits are basically three parameters. Number one is the voltage. Voltage measures the potential difference in the cell given by V. Do they give us? Yes, they give us 220 volts. So we write it 220 volts. Yes. Another parameter that do work in electric circuit is the resistance. The resistance, which we also call load. Resistance, which resists the flow of current in a circuit. It's denoted by R. Yes. Do they give us? Yes, they give us. They say they give us 110 ohms. Resistance is measured in ohm. So we have 110 ohms. Okay? The next one I want us to know is the current. The current that is flowing in the circuit given by I. Did they give us? No, they did not give us. No current. No current. Okay, finally is the time of the flow of the electric current. The time that the electric current flows. The time which is, you know that it will be T. Did they give us? No, they say we should find time. So we are solving to get our time. It is unknown. Okay, so these are the parameters that did work in the electric circuit. Which means that energy now will be, which will make us to write our energy as electric energy is equals to, are you following? Energy now is equals to the product of all these parameters written down here. Don't forget that you have different formulas for energy, yes, depending on the data given to us. We can solve energy with different formulas depending on the data given to us. For example, we have the first formula of energy, electric energy, as equals to IVT. energy E equals to IVT, which is energy is equals to I stand for current, V stand for voltage, and T stand for time. Yes. And we know that I, this I, from current electricity is equals to V over R. I hope you know that. I is equals to V over R. So if I now insert this I, this value of I, use it to substitute for this I here, energy will now become equals to this I here become V over R, then this V times this V times T times T. Yes. Which will simply be energy as equals to V times V give us V squared. V square T over R. This is a formula for energy. And this is another formula for energy derived from this. Now, as I said earlier, you have different formulas depending on the data, the parameters given to you in the problem. Now, look at the parameters, data given to us in the problem. We found out that we have in the, I want to check it with this. You found out that there is no I in these parameters. So, we are not going to use this formula. We are not going to use it. We now check the second one, find out that the second one is suitable for the question because we have V here and we are asked to find T, okay? So there's provision for it, and we also have R. So we use this formula to solve our problem. Let's go. So let's solve it. Decide. Okay, so I say energy energy E is equals to what? V square T over R. V square T over R. Let me clean this one. Okay. Now what do? We substitute this data, these values into this formula. That means we start solving. Let's start from the first one. The first one is energy. Did they give us energy? Yes, they give us energy. Say it takes to dissipate 121 kilojoules of energy. So that energy equals to 121 kilojoules. And we know the standard unit of energy is joule, not kilojoules. So we change this 121 kilojoules to joule, which will make us to write something like this: 121. This 121 times, to change it to joule, it will be times 1000. So times 1000. So it is 121. This 121 times 1000. It will now give us 121,000,000. Now it is in joule. Okay. Now I want to substitute these values into this formula. We start with the first one, which is the energy, and the energy given to us now is 121,000 joule. We have changed it to joule. So we write energy. We substitute 121,000,000. Put this equals to V. Did they give us any value of V? Yes, we are giving voltage. V is equals to 220 voltage. So we substitute 220 here. 220. But don't forget that this voltage is squared. So this 220 will be squared. There's an invisible times here, so it will be times what? T. Did they give us any value for T? No. We are asked to find the value of T because the question says the time it takes to dissipate. So time is T. So still write it T. You don't know the value. You are looking for the value. That's all to get the value. Put this over. R. Did they give us value for R? Yes, we are giving resistance R equals to 110. So we put 110 here. I always tell my students, for mathematics calculation of any kind comes to this format, the only thing remaining for you is to cross and multiply. Yes, to cross multiply. And to make it look uniform, more organized, I dash this one over 1 to make it look more organized. So this one will be in fraction and this one is also in fraction. And having done so, I cross multiply. Cross multiply means I've said this times this and this times this. I'll start with this. I say 121000 times 110. I write it out like this. 121000 times 110. 110 is equals to 220 square times t. Let's square the 220 first. 220 square will give us what? Let's square it to give us 220 square will give us what? It will give us 48400 times t. We still write it t. I'm not the value. So t. Okay. So I want to evaluate now. I want to evaluate this and this. I will now say 121000 times 110. It give us what? It give us 1331000. Okay, is equals to 48400 t. Okay, now because we are solving to get the value of t, which is the time it takes to dissipate 121 kilojoule of energy, which is what the question asks us to do. We will make t now the subject of the formula so that we can be able to find it easily. So I will write t, this t now is equals to, I first of all write this number 1331000 divided by what? The number with t now will come down and it will be divided by 48400. Hope you are following. If we evaluate it, it will give us what? Let's evaluate it first. You say 1331000 divided by 48400 will give us what? It will give us equals to what? 275. So our time, the time it takes to dissipate 121 kilojoule of energy in this electric heater is 275 seconds. And the measure in seconds. I hope you understand. It is a simple question on electric circuit, on electric heater. Yes, it's a simple question on electric